Hey guys, this is Pankaj, and today we are going to solve our next question, which is delete node from linked list present in an array. Like what it is saying is that it will be given a linked list. Let's say our linked list contains value like 1 2 3 4 and 5. 1 2 3 4 and 5. Okay, this will be the head, like head will be pointing to this node, and along with this we are given one array. Let's say that the array contains the value 1 2 and 3. Now what we need to do is we need to check throughout this linked list, and if the node value comes out to be same as what given in the array, then we need to delete those nodes. As simple as that. Fine. So this will be deleted, this will be deleted, and this will be deleted. Okay. Now what we need to return back? After deleting these elements, we need to return the linked list with the remaining element like 4 and 5. And this will be our new head. This is what the questions has asked. Fine. Now, before proceeding to the question, we need to understand that how we used to delete a node from a linked list. Specifically, when we are given uh, the same node that we needed to be deleted. What I actually mean is, like, if I have been given a node that is, let's say this one, 4, and let's say it is connected to some other nodes like 5 6 3, and I need to delete this node. I'm standing on this node only, and I need to delete this node. How can I do so? So there is one approach of doing this, that is what we will be doing. In this node we will take the value of the next node, that is the 5th. Fine. And the rest node will be same as usual. Okay. Now what the next step that we are going to do is, we will mark a temp node which will be marking to the next node, and this node, instead of pointing to this one like the next node, it will be pointing to the next node. Got it? So now this connection will be no longer there, and this node will be connecting to the other node. Now we can simply delete this one. Hence what we got as a result, 5 6 and 3. Like you can check, we have successfully deleted this 4. Okay, so let's quickly solve this question. Like we are given a array. Let's say the array contains the number 1 2 3 and so till n. Let's say it contains n number, and we are also having one a linked list. Let's say linked list contains uh, mth node. Okay, let's say it contains m node. So and this is the head. Fine. So we need to check for each node whether the element are there in the array or not. If it is there, we need to delete that one, right? So what we will be doing? So we will be checking for this in the complete array, right? So we will be looking uh, till nth time for one node, right? So if this is for one node, for to check for all the node we have to look it till mth time, right? And this will keep on going till mth time. So total time complexity will become O of n into m. Fine. Just for looking. Can we modify it? Yes, we can. If we use unordered set, what is an unordered set? Contains no duplicate element, first thing, and second thing is uh, like it is not in order, and we all know like its time complexity for lookup is O of 1 in average. If for lookup of every node, if it takes O of 1, then for mth node it will take O of m, isn't it? So let's quickly create this set, this unordered set of int data type. Let's name this as st. It will contain all the unique elements of this nums from beginning till end. Okay. Now what we require to do is, as of now what we have done, like we have created a set st, and this set is containing all the elements, all the unique elements that's required to be deleted. Let's say this was our linked list. Okay, so what I'm thinking to do is, we will create one dummy node which will point to this node as a next. This is our dummy node. Fine. And at the beginning what we are going to do, we will use two pointer. First will be this one, will be the previous pointer, and this will be the current pointer. Okay. Now if this current pointer contains the value that this stack is holding, that means this node is required to be deleted. In that case, we will mark this previous next. As of now, previous next is marking to this let me change the color, this node, right? But what I will be doing, this previous next will be marking to next of this current node, current next. We are removing this linkage between these two, and by doing so we are deleting this node. And then what we are going to do is, we will make our current pointer to point to the next updated current, that is this guy. Now our linked list will look like this. Will be the dummy pointer, this will be the next value, and so and so, and we will keep on doing this thing till our linked list traverser happens. And after completion, we will mark our new head as the next of this dummy pointer, because this was something which was created by us, and this was pointing to the head. So this will be the one which will be our new head. So let's quickly implement this thing. We need to create one dummy node. Let's say it contain a value as 0. It will be dummy only. At the end we will delete this one, no issue. at the initial, what we are going to do is this dummy car next will be pointing to the head as shown here. Like what we did, we created a dummy, and this dummy car next was pointing to this head. So that's only we did. After we need to create 2 pointers as well. One will be named as previous. This will be pointing to the dummy node, and another will be current, and this will be pointing to the head part. Fine. Now for traversing we will use one while loop, and we will traverse with the current value. If current exists, then we will keep on traversing. If it doesn't exist, that means we no longer need it to be like traverse, right? First thing what we are going to check while traversing is whether that value exists in our set or not. So if this set contains current ka value, then we are going to do something else. We are going to do something different. Okay, in if case what we are going to do, like if our stack contains that value, that means that is required to be, right? So what we are going to do, our previous next, it will point to current next. See, at the initial this was our current, and this was our previous. So previous next is connected to current next, so that we can unlink this code. Fine. So that will be previous connect is equal to after that we need to update our current. Okay, so now our current is pointing to previous connect, not to the same node which we are deleting, but the next of that. Fine. Okay, and what if it doesn't exist in this set? If it doesn't exist, that at that point what we are going to do is we will be simply keep on going forward. Like previous will go to the current, and this current will go to next of this current. Sorry, next of this current. Fine. After completing of all this thing, we will create our new head. And what will be our new head? Our new head will be something, a node which is being pointed by this our created dummy. Our dummy is pointing as of now to this 10. So this is our new head, isn't it? So what we are going to write is our new head will be something that this dummy next is pointing. Okay. After that, okay, so now there is no requirement of dummy, so we can delete this one. This was created by us only. Fine. And we need to return our new. Let's quickly submit and check. So yeah, accept.